So, good morning, STEM learners. This is again Sir Peter, your pre-calculus teacher. So we are now done with our video lesson number 1 about the definition of the ellipse, and video lesson number 2, which talks about the standard equation of the ellipse center at the origin. For this video lesson, we will talk about the standard equation of an ellipse, this time center at HK, meaning the center is located anywhere on the Cartesian plane. At the end of this video lesson, you should be able to illustrate the standard equation of an ellipse center at HK. So let us have a review about the standard equation of an ellipse center at 0, 0. So this is the standard equation. It's x squared over a squared plus y squared over b squared is equal to 1. And for a vertical ellipse, respectively, we have x squared over b squared plus y squared over a squared is equal to 1. Notice that both will be center at 0, 0. That's why originally it should be x minus 0 squared. And then here on the y part, we have y minus 0 squared. Okay, so there is an addition there, and then that is over the square of the semi major axis, and then the square of the semi minor axis equals 1. So this is the original form of the standard equation. So again, we have here the distances, C, A, and B, wherein A is always greater than B, and A is also greater than C distance. Now, how do we transform it now into a center at HK? Observe there is an additional part, which is the HK part. Same with the format of the equation of the circle and the equation of the parabola. So the x part always comes with h, and the y part always comes with the k value of the center at HK. Because remember, h is our abscissa of the center, and k is the ordinate. That's why they are always partner. So it's like spoon and fork, no? They always go along. Okay, but notice that still we follow the rules for the squares of the semi-major and the semi-minor axis. If the denominator of the x part is bigger than the denominator of the y part, then that is a horizontal ellipse. Consequently, if the denominator of the y part is bigger than the denominator of the x part, then that is a vertical ellipse. So this is how it would look like when the center is plotted on the Cartesian plane. So the center could be located anywhere on the plane. For a summary, you can also look at your SciPac regarding the formulas for the vertices, the foci, and the covertices, as well as the equations of the major axis and the minor axis. So on the table are the standard equation, and then we have the formula for the vertices. So when there is a change in h, you simply get the positive and negative of a. For the foci, we have h plus positive negative c, and then the k value retains. But in here, the h value retains. Okay, so kindly screenshot those parts that you need to remember. Anyway, you can also see those on the self-instructional bucket. Okay, so any question? Let's have the next one. So for the illustrative example, let us try to give the coordinates of the foci, the vertices, and the co-vertices of the ellipse with this given equation. So our given equation is quantity x minus 4 squared over 9 plus the quantity y plus 1 squared over 25 is equal to 1. So the first thing that you need to identify is the type of ellipse that we have. Since the y part is bigger than the x part, then what type of ellipse do we have? Very good. This ellipse is a vertical ellipse. So let me write it first. Identifying the type of ellipse that we have, and now determine the coordinates of the center. So in determining the coordinates of the center, we follow the same technique. So we invert the sign on the formula. Since in the formula, the x part is with -4, so on center, it will be +4. I hope you can follow. And in the formula, we have +1. So therefore, the center is at -1. Next is to determine values of distances A, B, and C. So to get A, simply get the bigger number on the formula. So it's 25. 25 here is A squared. Okay. So therefore, you will get what you get the square root of 25. So that will be 5. Okay. And then for B, so we have this one, but this is referred to as the square of the semi-major, minor axis, I mean. So this is the square of the semi-minor axis. So that will be the square root of 9. What is that number? That is, always remember that both A distances has a positive and negative counterpart, and B also has a positive negative counterpart. And for C, simply follow the formula in getting the C value. Since C squared is the longest distance, so we subtract it from B squared. So B squared is subtracted from A squared. So what we will get is the square root of 25 minus 9. So C now is positive, -4. Now, let us determine the measurement of the important points. Okay, so what are the important points on the given ellipse? So let's have coordinate of the vertices. P sub 1, P sub 2. So for the vertices, we follow the formula age. So you get the age value. So let me write it first. Our age is 4 and our k is -1. Following the formula, so we get first age. So that is 4. So both of them has values 4. And then we add and subtract it with a value. So a minus a, so we'll have a minus a and a plus a. So -1 minus 5 is -6. -1, again -1 plus 5 is +4. So the coordinates are 4, -6, v sub 1, and for v sub 2, we have 4, 4. The coordinates of the foci or foci, we also refer to them as the focal points. We have the same format. So since they are linear with each other, the vertices and the foci are linear with each other, so they will share the same x values for a vertical ellipse. So the formula is A again, this time, plus minus C. So we have -1 minus 4 is -5. -1, sorry, let's erase that one. -5. And then -1 plus 4 is +3. So we are now done with the vertices and the foci, which are linear. A non-linear point, which is the third point, are the co-vertices W sub 1 and W sub 2. This time, the key value will be copied. So the key value is -1. So we will just retain it for a vertical ellipse. And then we follow the formula H plus minus B. So that's 4 minus 3 and 4 plus 3. So what is 4 minus 3? That is 1. Then 4 plus 3 is 7. So therefore, these are the special points on the ellipse. But also, the 4 endpoints of the latus rectum are also very important. We need not to discuss them because based from the problem, we only need to identify the foci, the vertices, and the co-vertices. Oh my God. So it was erased. Sorry. Let me return it. So this is how the graph would look like. So observe the points. So let me identify them. This is one of the vertices. So let's check. So the vertices is at 4, 4. So the coordinates are correct. So we have 4, -6. Is that correct? That is our V sub 1, and this is V sub 2. Then we have 4, -5. The foci. 4, -5 is located here. Yeah. And then 4 E is somewhere located here. Okay. The vertices, we have 1, -1. Okay. And 7, 1. So observe. Again, the endpoints of the latus rectum also connects the curve. Okay, so it's very important. The latus rectum of this vertical ellipse is drawn perpendicularly along one of the foci. The same thing here. So these 4 endpoints here connects, gives you a perfect curve. So the endpoints of the this one, the lata recta in plural form, are also very important to form the smooth curve of the ellipse, because it would be difficult for us to construct if you connect one, so it will not be a smooth curve. So for it to become a smooth curve, we connect the endpoints of the latus rectum. Okay, so I hope that it's clear. Now let's have another example. What if the equation is a horizontal ellipse? Observe the a squared, because this should be the longest, and this will be now our b squared. So following the format, this type of ellipse is a horizontal ellipse. So it's very important to identify first what type of ellipse we have in the given standard equation of the ellipse center at HK. Now, Next part is to determine the center at age k. So obviously, the x part, coordinate with the x part, we get the age value. It's positive 2 here. So in the formula, it is negative. And then for the y part, it goes along with the age value of the center. So in the formula, it is positive 3. So that is negative 3. Next is to determine the distances A, B, and C. Remember that in formula, this will be A squared, and this will be B squared respectively. So these are the squares of the semi-major axis and the square of the semi-minor axis respectively. So again, we get the square root of 169. So that will be positive negative 13. And then this one will become positive negative 5. And again, to get the C distance, which is the distance from the center going to one of the foci of the ellipse. So we have square root of A squared, because this is the longest distance, minus the shorter distance, which is B squared. So we have 169 minus 25. So C now is equal to the square root of 144. And C is now positive negative 12. So I hope you understand. Next is to answer now the question. What are the coordinates of the foci, the vertices, and the co-vertices? So in other books, the co-vertices has no hyphen. In other it is co and then dash. So they are both true. So let's identify first the coordinates of the vertices. For the coordinates of vertices, we get a value first. So our age is negative 2 and our k is negative 3. Okay, so we just simply copy the k value because there is no change in the k value. So that is negative 3. Since this is horizontal, we now follow the formula age plus minus 13. So that is negative 2 minus 13, negative 2 plus 13. So let's answer it now for V sub 1. Negative 2 minus 13 is negative 15. Negative 2 plus 13 is, negative 2 plus 13 is 11. Next, we get now the linear point, which is the focal point or the foci. So again, whatever is the coordinate of the vertices, go along with the same values. So if they have the same negative 3 values for the k value, they will reflect the same values for y. This is only true for horizontal ellipse. And we follow the same format. We get the age value, but this time we compare it with C. So we add and subtract with C. So we have negative 2 minus 12 and negative 2 plus 12. So that is how easy it is. So let's answer. Negative 2 minus 12 is negative 14. Negative 2 plus 12 is 10. Next are the coordinates of the vertices or the endpoints of the. These are the endpoints of the minor axis. Remember that the co-vertices are not linear with the vertices and the foci. So instead of copying k, we will copy h value. Or this is only true for horizontal ellipse. So copy the h value for horizontal ellipses. Follow the formula. So we get a, we subtract and add a from the value of distance b. So that will be negative 3 minus 5, negative 3 plus 5. You follow the pattern. So we have negative 3 minus 5 is negative 8. Then we have negative 3 plus 5 is positive. So these are now the foci, the vertices, and the co-vertices of the given ellipse. The quantity x plus 2 squared over 169 plus the quantity y plus 3 squared over 25 is equal to 1. So let me give you a copy of its graph. Let us double check all the given points plotted on the Cartesian plane. Let's have the vertices. So the vertices is at negative 15, negative 3, so that is correct. For v sub 2, we have 11, negative 3. For the foci, are collinear with the center is located at negative 2, negative 3. And the focal point or the foci are negative 14, and 10, negative 3. You see them? And then for the endpoints of the minor axis, we have the vertices w sub 1, that is negative 2, negative 8, and we also have w sub 2. So this is how we do it algebraically. So this is the algebraic solution, but we can transform it into a graphical solution. So either way, you can still determine them using the graph, for as long as it follows the distances. Observe that A is our measurement of the semi-major axis. But when you want to find for the length of the major axis, that is to A. Okay? So when you count, that will be exactly 26 units here along this axis of symmetry. So that is 26. And then the length of the minor axis is twice the semi-major axis. So if the semi-major axis is plus minus 5, your 2b should be 10 because this is the length. Can you follow? So this is 10 units. And then for the measurement from focus to focus, so a focal point, another focal point, so that will be equal to 2c. So the answer is 24 units. So do not get confused with the value of a squared, b squared, and c squared, because these are the squares of the semi-major, the square of the semi-minor, and the square of the distance from center to focus. While 2a is the length of the major axis, 2b is the length of the minor axis, and 2c is the distance from focus to focus. While a is the length of the semi-major, b is the length of the semi-minor, and c is the distance from the center going to one of the foci. So I hope that is clear. Here are the references used in this presentation. So the graphs are through Symbolab. Did you learn something for today? So on our next video lesson, we are now done with week number 3 ellipse. We will now talk about week number 4 hyperbola. And on the first lesson, we will be talking about the definition of a hyperbola.